I'm Christopher Busby. I'm an expert on the health effects of ionizing radiation, and I want to talk to you about Fukushima and Chernobyl. What I want to say is about is that the models that are used to determine the effects of radiation always concentrate on cancer and leukemia. And so the current risk model will say how many cancers are expected after Fukushima and how many cancers were expected after Chernobyl and so forth. But we know from Chernobyl that radiation causes a whole range of diseases, and one of the diseases that it seems to cause is heart disease. I want to talk to you about heart disease effects in children. Now, a colleague of mine, Professor Yuri Bandashevsky, became quite famous because he studied the effects of Cesium-137 exposure to children in the areas that were contaminated by the Chernobyl accident in Belarus. He discovered, in the late 90s, he discovered that the children who were contaminated to the extent of having only 20 to 30 becquerels per kilogram, which is not very much, of Cesium-137, were suffering cardiac arrhythmias, the heart wasn't beating properly, and they were suffering heart attacks and dying. And it's a very serious matter. So it wasn't a question of leukemia and cancer in these children, although that occurred as well, but there were very high rates of heart disease in these children. So the children were manifesting heart diseases which are normally only found in old people. And this got me thinking about how this could be at what appears to be quite a low level of contamination. So I started looking into this, and what I found is truly extraordinary, which I shall share it with you. The heart of a child is at the age of about 2 to 5 is about this size, and at the age of about 10 it's about this size. And we know from measurements that have been made how many cells there are in the heart of a child. A 5-year-old child has a heart which is approximately 220 grams in weight. A lot of it, of course, is blood. So if you take the blood out and just you leave the muscle tissue, there's about 85 grams of muscle tissue in the heart of a child aged 5. This is all data. Now we actually know also the size of the heart muscle cells. So we know how many heart cells there are in a child's heart. There are about 3 billion muscle cells in a child's heart. So this is a number, 3 billion. And what we can do is we can put 50 becquerels per kilogram of cesium in a thought experiment. We can put it into this heart muscle, and a becquerel is 1 disintegration per second. So we can see how many disintegrations, that's how many electron tracks come from this Cesium-137 in a period of about a year. And when we do this sum, and it's really simple, it can be done on the back of an envelope, what we find is that there are many, many more electron tracks traversing the cells than you can imagine. And in fact, it works out that if only 1% of those cells were killed by the electron tracks from that level of Cesium-137, if only 1% were killed, you would lose 25% of all the muscle cells in the heart. This is very serious because the heart is an extraordinary organ. The muscle cells in the heart are autonomous. They just contract and they contract and they contract for the whole period of the life of the individual. And every day they pump 7,000 litres of blood through the body. Truly extraordinary. And we live for 70 years. So this heart beats away continuously for the whole of your lifespan. But of course these cells are non-replaceable by and large. It turns out that only 1% of these cells can be replaced in a year. So if these cells get damaged, or if a particular number of these cells get damaged, they cannot be replaced in a short period of time. So a year's exposure to 50 becquerels per kilogram of Cesium-137, and incidentally, Cesium-137 we know from experiments binds to muscle. So this is where it goes, just like iodine goes into the thyroid gland and strontium goes into the bone and it goes to the DNA. Cesium-137 goes to muscle, so it will concentrate in the muscle tissue of the heart. So this child's heart, after 1 year of exposure to that level of cesium, which is quite a small level, will have approximately 25% of its cells destroyed. Now, we would therefore expect to find effects, and the same effects that were found by Bandashevsky. And it does seem, from what people have been telling me about children in the Fukushima affected area, that they are actually suffering heart attacks. So there are two things that follow from this, which are terribly important. The first thing is that children in that area should immediately be scanned using ECG, electrocardiograms. All hospitals have these devices, to see whether they have conduction problems, because the first manifestation of this damage to the heart muscle cell will be conduction problems, which can be shown on these ECGs. And in fact, this is how Bandashevsky found this. And incidentally, Bandashevsky, when he reported this, was sent to jail, and the government wouldn't believe it, and they said he was scaremongering. And so they sent him to jail. He was in jail for several years until eventually Amnesty International and the European Commission, the European Parliament, issued him with an international passport, one of only 25 that have ever been issued, and got him out of jail. So I worked quite closely with Bandashevsky, who is a hero. He received the Edward P. Radford Memorial Prize for Radiation Biology at the Lesvos conference, where he gave this paper that showed that there were these increases in the heart disease in the children. So the first thing that has to be done is that the children have to be checked out for conduction problems with an ECG.
Evacuated.
And and of course, if any of them are suffering from these problems, they should be immediately evacuated. But if any of them are suffering from these problems, then all of the children should be evacuated, because it means that there will be subclinical effects from this Cesium-137 in heart muscle. And it will not be repaired. Heart cannot be repaired. Heart tissue cannot be repaired. These children will suffer for the whole of their life and will die young. Which brings me to the second point. The second point is this, is that if you die from heart attack or heart disease, you will not die from cancer. Because cancer is essentially a disease of old people. So you get genetic damage and it goes on and on and on. Eventually you get cancer. By and large, what happens is that the cancer rates go up very sharply as you get old. But I can tell you this, that the heart disease effects go up very much more quickly. So what you will find in areas like Fukushima that are contaminated with these radionuclides is not necessarily an enormous increase in cancer. There will be an increase in cancer, but you will find a big increase in heart disease. And actually when we look at Belarus, we find both of those things. We find an increase in cancer, but we find a big increase in heart disease, an enormous increase in heart disease. And as a result of this, the demographic index of the Republic of Belarus has fallen sharply after the Chernobyl accident, and now has gone into negative replacement. So in fact, if it goes on like this, the population of Belarus will disappear. And this is what we will expect to see in Fukushima. So I'm warning you all now to start looking out for heart disease, heart attacks, and keep getting the children out of there quickly. This is all simple stuff. You can do these calculations, and I've done these calculations, and I've produced a report which will be put on the internet shortly, and that you can have a look at. And we have also, the European Committee on Radiation Risk has also released early the Bandashevsky paper that he gave at the Lesvos conference, and that is on the website of the European Committee of Radiation Risk, which is www.euradcom.org, EURADCOM. So thank you for listening.